Hi, I'm Timothy Brusella. Today we're doing some related rate problems with my Math 1325 class. And first of all, a little brief introduction. Related rates address those problems where we're differentiating with respect to a different variable, a third variable other than x or y. We have a third variable, t, for time. And so we're looking at the rate of change of some quantities over time, which to me are some some of the most significant applications of derivatives. How is a quantity changing as time passes, what have you. So we're differentiating with respect to a third variable, so we'll be looking at dx dt and dy dt. I'll still call them x prime and y prime, but I'm going to be making a note that I'm differentiating with respect to t in this case, not x or y. dx dt and dy dt are called related rates. That's what, hence the name of this section, related rates. And you'll have to remember how we were differentiating implicitly or whenever we were doing that. To me it was yesterday, but maybe it wasn't just yesterday for you. But you'll have to remember implicit differentiation. I have some homework problems here that I printed out, and I thought we'd do a few. Given that x and y are functions of time, find the indicated rate of change. On number 1, they want us to find dy dt. They give us x and y, but remember, every time you differentiate an x, you're going to be picking up an x prime, which every time you differentiate an x, you'll be picking up an x prime, which is a dx dt. And every time you differentiate a y variable, you'll be picking up a y prime, which is a dy dt. So they want us to find y prime when x is 3 and y is 4, and they're giving us that x prime is 2. They want us to find y prime, and here's the function, y cubed equals 2x cubed plus 2. So let me flip over here. Here I have the problem written down for us. We want to differentiate with respect to time. I'm going to use that notation I use for implicit differentiation. And remember, I said if the variable you're differentiating is different from that variable, that subscript I just wrote there, and remember the subscript is determined based on the letter that appears on the bottom part of this differential notation, dx dt. We're differentiating with respect to time. Differentiating y cubed, that would be a 3y squared, times the derivative of y with respect to t, which I'm going to denote just y prime for brevity. The derivative of 2x cubed, that would be a 6x squared, times the derivative of x with respect to t, so I got to stick on another x prime. We have to stick on another prime there, this time an x prime, and the derivative of 2 is 0. And we're looking for dy dt. So we're trying to solve for y prime. I guess we could go ahead, let's divide both sides. Sometimes I may decide just to plug the numbers in that I know immediately. I know x prime is 2, I know x is 3, I know y is 4, so I could do that right now, but I think I'm going to go ahead and solve for y prime first. I'd have to divide by 3y squared to give us y prime equals, well, 6 divided by 3 is 2, and we have an x squared times x prime. What's the only thing we have left in the denominator? Remember, we cancel the common factor of 3, so all we have left in the denominator is y squared. So let's start plugging in the numbers they gave us. We're looking for y prime. X is a 3. X prime is what I'm denoting, of what they're denoting, x dx dt. And y squared, let's see, y is 4. So that's what a let's see, a 9 times 4, that's a 36/16. I guess I could have canceled one factor of 4 automatically and gotten just a 9/4 for my final answer. So come over. Let's see. It looks to me like My Math Lab here on number 1, round to 2 decimal places. So we got 9/4. So we'd have to round. No, it's not really rounded. It's going to be what, a 2.25 for our final answer. And we differentiate. Let me summarize. We differentiated both sides with respect to t. Since neither of these variables were t, but they are functions of a third variable t. Every time you differentiated one of those variables, you had to pick up the prime of it. And once we did that, just plug in the numbers they gave us. Let's do another one. Number 2. Number 2 is pretty similar. They want us to find dx dt. So using my prime notation, which prime would that be? That'd be, I'm looking for x prime when x is 3 and y is 3, and dy dt, that's y prime. No, excuse me. Y prime equals -3. Oh, there, I had to stand up and get my cup of coffee. Here's the function. Xy equals x plus y. What derivative rule are we going to have to use to differentiate xy equals x plus y? What operation's going on there? We're going to differentiate with respect to time t, and what derivative rule will we need to use? In particular, here that's just a sum, so you differentiate the terms individually, but for x times y, I think I just said it, it's a product, so we're going to have to use the product rule. So using the product rule, the derivative of x, we treat it as x times y, the derivative of x with respect to t, the derivative of a letter by itself is just 1, times the derivative of x, which is x prime. Well, that's sort of hard to see, isn't it? X prime. I want to make sure you see that prime mark. And the derivative of y, using my prime notation, that's just y prime. So using the product rule, we're going to get, let's see, well, I guess I'll push it up a little bit. It's the derivative of the first, so that red x prime times the second, the original second, that's a y, plus the derivative of the second, y prime, times the first, which is just an x. The derivative of the first times the second plus the derivative of the second times the first equals the derivative of x is just an x prime plus the derivative of y. The derivative of a letter by itself is just 1, but we then have to stick on a y prime. Oh, we have a lot of primes floating around here. And let's see, we're trying to find, looking back up here, we're trying to find dx dt. So we're looking for x prime. What is x prime? So why don't we get all the x prime terms on the same side? I'm going to get all of the x prime terms on the same side. I will have an x prime y. I'm going to move that x prime over to the left. So minus x prime equals, I have a y prime. I'm going to subtract y prime times x. I'll factor an x prime from both of the terms on the left. So I'm factoring out I'm factoring out an x prime from both of the terms on the left, and what am I going to have left here inside these parentheses? I'll have a y minus here. Yes, I'll have a 1. Remember, x prime times y is x prime y. X prime times that minus 1 gives us minus back that minus x prime. I want to get x prime by itself, so I'm going to divide both sides by y minus 1. And here's the thing I'll plug into. X prime equals, I better push this up some. X prime equals, we have a y minus 1 on the bottom. We have a y prime minus a y prime times x on top. Now we'll make the substitutions. Remember, they told us that x is 3, y is 3. Here's the numbers we're plugging in. X is 3, y is 3. Y prime is negative 3. So we're looking for x prime. So here's the stuff we're plugging in. Here are the numbers we're plugging in that were given to us in the problem. So I'll do that just to keep them separated from this thing here that we're running in together. So we have x prime equals, y prime is negative 3 minus negative 3 times positive 3 all over y minus 1, 3 minus 1. That's giving me a denominator of 2, and let's see, that would be a negative 3 plus 9. Negative 3 plus 9, I'm getting a positive 6. So what are we getting for our rate of change of x? X prime, which is the same thing as dx dt, using that notation, 6 divided by 2 is equal to positive 3. So, whatever x is representing, at this point in time, it's increasing at a rate of 3 units per time unit, whatever the time is being measured in, minutes, seconds, years, what have you. And there it is. We started off, we used the product rule to differentiate x times y, but since we were differentiating with respect to time, we had to use x prime and y prime. We differentiated, we solved for x prime since that's what we were looking for, and once we did that, we substituted in the numbers they gave us. And finally, we got substituting in those numbers into the equation for x prime. We got x prime, the rate of change of x with respect to t, equaling a positive 3. Let's do one more. Oh, by the way, so we come over here, and that was number 2. Let's see, where are we? Right here. That was number 2, dx dt. I'd write in a 3 right there. It says round to 1 decimal place, that's needed. We don't need to round anything, so it's an integer, so we'll just leave it as 3. Let's do one more. Let's do number 4. On this list that I have here. Let me pull it down. Here's number 4. Given that x and y are functions of time, find the indicative rate of change. So they want us to find x prime. I'm covering over problem number 5. We'll probably do that in a little bit, but I don't want you reading about cantaloupes right now. So they want us to find x prime when y is equal to 3 and dy dt is equal to 2. Now wait a minute. When we differentiate with respect to time, we're going to pick up an x and x prime, a y and a y prime. They didn't give us an x value, did they? No, they didn't. They just told us what y is equal to. So when we're ready to substitute in, we'll probably have to determine the value of x as well. And to do that, we know the value of y. Y is 3. We're going to have to plug a 3 in for y and solve for x. So we're differentiating. Let me make sure this is, yeah, there it is. I'm going to differentiate with respect to time. Oh, let me take another drink. I don't know why I called that stuff coffee earlier. It's green tea that I'm drinking. So we're differentiating with respect to time. The derivative of x cubed, that's a 3x squared. Anything else? Yes, the derivative of x with respect to t, so an x prime equals, here we'd have a 28 y cubed times y prime, and the derivative of that minus 559 is 0. So, oh, that's not too bad. So let's see, which one are we looking for? We're trying to find x prime. And there's only one x prime right there, so I'm going to solve for x prime. I need to get rid of that 3x squared, so I'll divide both sides by 3x squared. So I'll have x prime equals, that red isn't showing very good, is it? So it's a 28 y cubed y prime all divided by a 3x squared. So we're going to have to plug in 3 for y, that's what they gave us. We have to plug in 2 for y prime, but they didn't give us an x value. So we got to find x first. To find x, we go back to the original problem. Here we are. I'm going to do this. Let's see. Let's find x. We need x, so I'll say find x. I'm going to come down here and do it. What was the original problem? X cubed equals 7y to the 4th minus 559. So we said y is equal to 3. So we're going to plug in 3 for y. That orange, is that orange? Yeah, I guess it's showing okay. So I'm plugging in 3 for y. And let's see. 3 to the 4th is 81. And 81 times 7, that is 567. So we have x cubed equals 567 minus 559, and I can do that in my head. That's what? X cubed equals 8. So with that in mind, what does x have to equal? Taking the cube root of both sides, what number can you cube to give yourself an 8? I think that would be a 2. So when y is equal to 3, that's the y value they gave us. When y is equal to 3, x is equal to, when y is equal to 3, x is equal to 2. So let's make a note up here. X is equal to 2. X is 2. Start plugging in. We're trying to find x prime. So we have x prime equals 28. Y is 3. Y prime is 2 all over 3 times x is 2. That's that x value we found. So we can cancel a, let's see, before I start, we can cancel a 2 above and below. We can cancel 1, 3. So all we have is 9 times 28, and 9 times 28 gives us, does that give us, let's see, so I had a 28 into y cubed, that's 3, and a y prime is 2. I'm double checking all of my calculations here. 3, as I see some looks, someone's disagreeing with me, but they're not telling me what they're disagreeing about. So let's see. That's a 3x squared. I agree there. That's a 28. 4 times 7, yeah, that's 28. So 28. So 28 times, okay, that's a 9. And then I have to divide that by 2. Yeah, my calculation's right. 126 for my final answer. So, anyway, I think I'll take a break and drink some more of this green tea, and maybe then we'll do a word problem involving related rates. Okay, bye-bye.